In this clip we're going to have a look at the different types of decimal fractions, and much of the Vedic mathematical treatment of decimal fractions relies on the knowledge of what the different types are. And there are three. The terminating decimals such as 0.1, 0.3, 0.25, recurring decimals like 0.3 recurring, and then partly recurring decimals as well. So let's first have a look at what makes a terminating decimal. Well, if we take a very simple example, 1/2, we know that it is 0.5, and 1/4 is equal to 0.25, and that's terminating, and 1/8 is equal to 0.125, and 1/16 is equal to 0.0625, and all of these are terminating. Now, if you have a look at the denominators, they're all they have factors of 2. So 16, for example, is 1/2 times 2 times 2 times 2. Likewise, 1/8 is 1/2 times 2 times 2, and 1/4 is 1/2 times 2. And you may notice that the number of factors of 2 is equal to the number of digits in the decimal. So here we have 3 2's as the factors of 8, and there are 3 digits in the decimal fraction. You'll find the same with fifths. So 1/5 is equal to 0.2, 1/25, 1/25 is a fifth of this, which is 0.04. And likewise, we find that the number of digits here in the decimal for 1/25 is equal to the number of factors of 5 that there are in 25. And also we have 1/10 is 0.1, 1/100th is 0.01, and 1/20th is equal to 0.05. Now what happens is the rule is that the number of 2's or 5's or 10's as factors of the denominator give the number of digits of the decimal. So with 1/20th, 1/20th is 1/2 times 10. And we get 2 digits in the decimal from these 2 factors. So wherever there are 2's or 5's or 10's as factors of the denominator, that denotes how many decimal digits there are, and also only produce terminating decimals. Terminating decimals come from nowhere else except for denominators with 2's or 5's or mixtures of 2's or 5's in the denominator. Now we get to recurring decimals. Recurring decimals, any other prime factors in the denominator produce completely recurring decimals. So 1/3 is equal to 0.3 recurring. We put a dot above the 3, and we have 1/7 is equal to 0.142857, and we put a dot above the first digit of the pattern and the last. 1/9 is equal to 0.1 recurring. 1/11 is equal to 0.09 recurring. And these denominators have only prime numbers as their factors, which are not 2's and 5's. So we can think of 1/13th, 1/17th, 1/19th, which has 18 digits in all, and all of those fractions will have purely recurring decimals. Then when we come to partly recurring decimals, these arise from having mixtures of factors 2s and 5s with other primes. So for example, 1/6, 6 has factors 2 and 3. The 3 produces a recurring part and the 2 a non-recurring part. So this 1/6 is 0.16 recurring. The 6 recurs, the 1 doesn't. And this digit is produced from the 2 and the recurring part from the 3. And the number of 2s or 5s in the factor of the denominator denotes the number of non-recurring digits in the decimal fraction. And after that, we just have recurring, the recurring patterns. One other thing, I noticed that I put down 1/9 and 1/11. These mirror each other, and you will see why in a minute, because 2/9, I could write that as 0.2 recurring, or 0.22, 3/9 is 0.33, etc. 4/9 is 0.44, etc. And now compare this with the 11ths. We have 2/11ths is equal to 0.18 recurring. 3/11ths is equal to 0.27 recurring. 4/11ths equal to 0.36 recurring. And here you will see a mirror. These numbers here appear in the 11 times table, and these numbers here appear in the 9 times table. So that's quite a fun thing to know about. In the next session, we'll look at how to turn decimal fractions back into ordinary fractions.